Good evening, everybody. Today I'm back with a problem in which we have to convert NFA to DFA with epsilon moves and without it. So it is like that. So in the method 1, we have to consider the epsilon moves. This method involves capturing the states that can be reached through epsilon transitions and then combining them to form new states in the DFA. This process this process also ensures the DFA accounts for all possible states and transitions, including epsilon moves to present in the NFA. Then you have the second method, construct converting the NFA to DFA without the epsilon moves, in which we don't require the use of the epsilon. Here we do the conversion by making the table. This method typically involves creating a transition table that includes all possible combinations of states in NFA and identifying the transitions among these states. While this approach may be more straightforward, it may result in a larger DFA. So in this slide we have given with the complexity analysis. Obviously, in the first method, by considering the epsilon moves, there we require less time, and that DFA is also smaller in size. And the complexity is very crucial for evaluating the efficiency of the conversion process. Then we have the state combination, that is identifying and combining states which can be reached through epsilon transitions, playing a key role. This process involves creating new states in DFA that capture the combined behavior of the original states, accounting for non-deterministic nature of transitions. And we have the deterministic enforcement, whose primary objective is to enforce determinism in the resulting DFA, which involves ensuring that each state in DFA has unique transition for every symbol in input alphabet. Addressing non-determinism in the NFA is a very critical aspect of this conversion method. Then in the second method, conversion without epsilon moves, we have transition table construction. When converting from an NFA to a DFA without considering epsilon moves, constructing the table, which becomes the basic requirement for this process to be achieved. Here we capture all the possible combinations of states from NFA indicating transition for every symbol and input alphabet. And we have state identification. We identify the resulting the states in the resulting DFA, which is a significant aspect in this conversion. Each state in DFA represents a unique combination of states from original NFA, and understanding of each state in recognizing patterns is crucial for this identification process. Then considering minimization of resulting DSA, which is an important optimization strategy. The size of DFA obtained without considering epsilon moves can be large, and minimizing the number of states can lead to more efficient pattern recognition and memory utilization. Then we have some examples of converting NFA to DFA. What is initial NFA? A visual representation of NFA which showcases its state transitions and presence of epsilon moves, if any. Then in the NFA to DFA with epsilon moves method, a step-by-step conversion of NFA to DFA including handling of epsilon transitions in process. An NFA DFA without epsilon moves. In this we construct a table and solve the problem. So as we are given with the problem in which there are three states Q, R and S, and Q state has a self loop of A, and Q on passing with epsilon goes to state R, and here also we have an epsilon, and the R on passing with epsilon goes to S, which is a final state, and S also has a self loop, and all these states B state R has a self loop of B and S also has a self loop of C. So for solving this problem we have to make first the epsilon NFA it's stable. So here we have the transition function. In row side we have the loops as A, B, C and also epsilon, and in the column side we have the states Q0, Q1, Q2. We are marking Q0 as the initial state and Q2 as the final state. So if we see Q here delta of Q0 comma A gives you the Q0 that is Q itself, and when Q0 is with B it gives you a phi nulls, because here you can see it doesn't have a relation with the B, and similarly with C, Q0 on Q on C gives you null phi, and on epsilon when we give delta of Q0 comma epsilon we go to the state R. Similarly for second from R to this is R to when we are given with the delta of R comma A, it gives you phi null. When we give R on R state we have self loop of B, so we go again to R state, and R on S goes to R on epsilon goes to the state S. So coming to the final state from R to S, from R to S, when we give S a transition delta of S comma A, we get phi because A doesn't have any relation, like it doesn't have any join, so it is phi. Then similarly delta of S comma B gives you phi. Similarly delta of S comma C gives you S, because S has a self loop of C, and similarly S delta of S comma epsilon gives you phi. In step 2 we find the epsilon closure of each of these state. So epsilon closure of Q0 is Q0 Q comma R comma S, and epsilon closure of R is R comma S. This means that epsilon is in which all the is in which all the states, like if you consider from q naught, you have q naught, q to r, then from r to s we have epsilon, and from state r we just have r and s, and from s we have only s. And moving to the step 3, we have to now make an F8 table which is marked by delta dash. So here we take here in this how will we come to the formulas, like we take delta dash of q comma a, which is epsilon closure. This is the formula: epsilon closure of delta of v, epsilon closure q comma a, so which is equals to the delta of here. We now consider this thing q naught comma a union of r, union of delta of r comma a, union of delta of s comma a, which is equivalent to epsilon closure of q naught, which is q comma r comma s. Similarly, we'll make for all of them. We'll find for a delta dash of r comma a. So which comes like this. That is delta of q naught comma q comma b, that comes as r comma s. Then when we go with delta of r comma a, which comes as 5, and delta dash of r comma b gives you q1 comma q2, and delta of r comma c gives you q2. Similarly, delta of s, delta dash of s comma a gives you 5, delta dash of s comma b gives you 5, delta of s comma c gives you q2. Now we have to make the minimized DFA, which will look like this. So here q, r and s all will be the final states. So from the table we observe that on giving a, it comes to the same state, and a comma b from q moves to r, and b and from r when we give b comma c it goes to s, and when we also have a comma b comma c, when we pass on q it goes to the last stage as s. Thank you guys for being till the end.